Hey, hi, Lucia.
Hi, Aman.
Hey, hi. How are
And
you?
it's us again.
That's great.
What
Yeah, I don't want to be
Oh,
sitting alone, so that's great you're here.
what was that?
I'm saying it's great you're here. I don't want to be sitting by myself. I want to talk
Oh,
to you.
okay,
Yeah.
great. It's my lunch hour, so I said perfect timing.
Oh, that's great.
Uh, so I have a couple of questions.
Uh-huh.
For the nomenclature, the
Mhm.
thing that I'm really confused is the atoms that are not in type 1 and 2 and they're in type 3. I forgot what
Oh,
merge
there's no
is for
type
each
3.
of those.
There's no type 3.
No?
No, there's no
Okay, so I
type
think
3.
that's
There's
what the
type 1 and type 2.
okay. So I
There is.
think you know how it says on.
Yeah. Yeah, go ahead. You were saying something?
So you know how the type 1 has group 1, group 2, and
Right.
some of group 3?
Right.
So the ones that are metals,
Uh-huh.
I just forget the ones that are in group 3 and the metals and the charges.
So in group 3, can you see the screen?
Yes.
Yeah. So group 3 has aluminum, gallium, and indium on the periodic table, and all of these are plus 3 charge.
Ah,
Group 1 is plus 1. Group 2 is plus 2. Group 3 is plus 3. But not all of them, but only aluminum, gallium, indium.
on group 3.
Yeah, in group 3. Some textbooks will
And
just
then
say aluminum, so that's also okay. Some textbooks will say
and
that aluminum is type 3, gallium, indium are just like type 2. So that's also okay if you read that. Yeah. You were saying something, Alicia? Hello? Can you hear me, Alicia? Hey, Alicia?
then
Yeah, I think you got some network
on
issues. I can't hear you well.
hear me?
Here, Can you can you hear me now or no?
Yes, I
I think
can hear
I think you have a poor internet
hear
connection.
me.
It's stuttering. Okay, let's see. Can you hear me or no?
Yes, can you hear me?
Yeah, I now can hear you, but again, cutting off.
Hello?
Yeah, yeah, I can hear you now.
Okay.
Yeah, 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 okay. So yeah, type 1,
Okay, good. I
right.
I'm on my phone. sorry.
It's still if you can hear me clearly, then you can just post your questions on the chat, and then I will speak if you can hear me well. If you can hear me, thumbs up. Okay, all right. So for your metals in type 1, you see, if you are in group number 1, so if you're sodium and potassium like that on the product table, all of them are +1. Let me open the product table so that it's more clear. So okay, so if you see here on the product table, all your group 1 here, so lithium, sodium, potassium, rubidium, cesium, francium, all of this place here, group 1 is +1. All of this group 2 is +2. Beryllium, magnesium, calcium, strontium, barium, radium. All of these are +2. And then you jump to aluminum, group 3, aluminum, gallium, indium, this is +3. So that's type 1. Okay. And then there are some couple more which have a fixed oxidation state, and that's why we call them type 1. And that includes cobalt, which is always +2, nickel, +2. I mean, it can be +3 as well sometimes, but cobalt +2, nickel +2, zinc +2, CD, cadmium +2, and Ag and Au, silver and gold, they're always +1. So that's type 1. So if you make a list here, we'll see that our group 1 is +1, our group 2 is +2. By the way, these are all type 1, okay? This all falls under type 1. Group 2 +2. Group 3, in which you have aluminum, gallium, and indium, they are +3. And then you go to some more transition metals, which are also type 1. So we'll make a list. Cobalt is +2. We've got nickel, +2 or +3. And then we've got cadmium, always +2. And we got zinc, always +2. And then we got Ag, +1. And then we got Au, +1. So gold and silver are +1. And then +2, +2, +2. And then you go to group 3, aluminum, gallium, indium, +3. Group 2, +2. Group 1, +2. So that's type 1. So if that made sense, let me know. If you have questions, let me know. If are you able to say anything, try to speak. Maybe I can then hear you.
Hi,
Hey,
can you hear me?
yes, but I mean, it still is getting it's better.
I tried to log in through a PC, so.
Yeah, that should be better. So maybe you want to turn off your phone then, maybe. Because right now I can see you're connected through both iPhone and your computer. And that's why I'm hearing myself back.
Okay.
I I don't know where's your voice coming from. I think it's your iPhone where I'm hearing you from. Speak something. Are you still there, Alicia? Okay, so send me more questions or. Okay, Alicia. So if I understand your question, you're asking me, how do we know what charge we use for conversion? Example, SO4 -2, where does it get the H2 from? Okay, so first of all, you simply got to memorize your polyatomic ions, right? So for your polyatomic ions, you got to remember that sulfate is always -2. You got to remember that phosphate is -3. You got to remember that ClO3 chloride is always -1. So that charges you have to memorize, okay? For just these three examples that we have just seen right now, they actually are easier to remember because if we match them with the product table, chlorine is always -1 because it's in group number 7. And then you can see sulfur is always -2 because it's in group number 6. And then phosphorus is always -3 because it's in group number 5. So this works for these, but for other ones like nitrate or carbonate, that does not work. Now that's one thing. I think the question that you're asking me is when they become an acid and we add H plus to them, how do we decide how many H plus we need to add? For that, it depends again on the charge that you see here. Since this is -2, we'll need 2 hydrogens, each one with +1 charge, and that will then cancel the charge of SO4. So if you see this is SO4 -2, we can simply do the crisscross. You take this 2 and you put it down here. See, this is +1, so you take this 1 and you put that down here. So what does this become? So just give me a second. So once we Once we do the crisscross, it becomes this. H gets the 2, so it gets this 2. And then you have SO4, and it gets the 1, so you never put the 1. If that made sense, let's see, let me know. Then we'll do the other example. Okay. Yeah, so once we then, if we do the second one, if we try this one, we can do the crisscross. Take this 3, put that down here. Take this 1, put that down here. This will become then H, then that's 3 from this 3, and becomes PO4, H3 PO4. Do the next one. This is -1, this is +1. They just cancel out. 1 goes down here, 1 goes down here. You don't have to write a 1, so you just write this, HClO3, and that's the final answer. So these are all the polyatomic ions, and you have changed them into the acids. So these are acids now with the hydrogen. Right, great. So let me know if you want to ask something else. You're welcome, Alex. If you have any questions, please send me your question. You can ask your questions. Alex, if you wish, you can also send your questions through the chat if you want. How do we know what you're asking when we have a binary and oxy acid? Can you just come? Sure. So I'll never say on the exam binary or oxy acid. I'm not going to use that word. But we classify acids into 2 different types. So our acids are 2 types. One is binary acid, and one is oxy acid. Okay, so the main difference between binary and oxy acid is, now one thing is both have hydrogen. Okay, so never think that one has hydrogen, one does not. If you have an acid, it's going to have hydrogens. But binary means it's not going to have oxygen. It's not going to have a polyatomic ion. Oxy acid, on the other hand, will have a polyatomic ion inside. So if you take a simple example, which you also saw in the class, HCl, which is made up of H plus and Cl minus, this guy, HCl, is a binary acid because Cl negative is not a polyatomic ion. It's just an ion. It's not polyatomic. It's just one atom. Polyatomic are things like this, ClO3 -1. That's a polyatomic ion when you have chlorine with oxygen, 2 different atoms. So this is a binary acid. And polyatomic, when you have a polyatomic ion, let's say your polyatomic ion is ClO -3, and then you add H plus to this guy, it becomes HClO3. This is an oxy acid, and this is a binary acid. Now, the names for these guys are a little different, okay? And you're going to see how we name them. For binary acids, we always use a prefix hydro. Okay, we use this prefix hydro for binary. For polyatomic ions, there's no prefix. Okay, so when you see HCl, we call this guy hydro. Since this guy is coming from chlorine, both the acids you will see will end with ic acid. Now, when we go to oxy acids, there's actually 2 endings. We'll learn 2 endings. But binary acid, they always start with hydro and they end with ic acid. So this is the prefix and this is the suffix. Hydro is the prefix, ic acid is the suffix. So when you have chlorine in there, what do we want to call this guy? Hydro. Then you have a chlorine, so we'll say chlor. And then we'll add this suffix, ic acid. So hydrochloric acid. Now, how do we name this guy? These guys, as you know, does not use any prefix, so no prefix. So you don't use hydro for this guy. So what do we call this guy? Where is this guy coming from? So there are two things that you got to decide here. One is whether this polyatomic ion is coming from 8 or whether it's coming from 8. Okay, so let's say you got chlorate, that's one polyatomic ion. The second option you got is chlorite. So if you have chlorate or 8, this guy will always end with ic acid, just like the binaries, they end with ic acid. So does your oxy acid. So your oxy acids can be either ending with 8 or come ending with 8. If it's ending with 8, you call them ic acid. When they add with 8, you call them us acid. Okay, so this is one prefix if they end with 8. The polyatomic ion ends with 8. If the polyatomic ends with 8, then you call them ic acid. So let's see the example. So first is that you, let's say this is the acid, HClO3. So first you ask yourself, which polyatomic ion is this made from? So you try to see what is the polyatomic ion inside. The polyatomic ion inside is this chlorate. So that's important to remember the polyatomic ions. So when you realize that this is chlorate, then you learn that whenever you have 8, it's going to end with ic acid. So you make this chloric acid. So that's the final answer, chloric acid. On the other hand, if you had HClO2, okay, HClO2, what is a polyatomic ion? The polyatomic ion here is chlorate. So when you have 8 in your polyatomic ion, it's going to end with us acid. So now we're going to call this chlorus acid. Okay, so now this is the name for HClO2. Chloric acid is the name for HClO3. Okay, so that's your oxy acid. So now we learned two things. One, we learned the binary acid, that's not too much. You just have to add hydro in the beginning and ic acid at the end. That's it, and you stop. Whereas for oxy acids, first you have to identify what polyatomic ion do we have. Do we have a polyatomic ion that ends with 8 or does it end with 8? If it ends with 8, you end the name with ic acid. If it ends with 8, you end the name with us acid. So that's why we saw these two examples. HClO3, HClO2. This guy is chlorate, this guy is chlorate. Chlorate will end with ic acid. Chlorite will end with us acid. So that's the difference between chlorous acid and chloric acid. And if you say hydrochloric acid, then that's this, HCl. Hydro is telling you it's a binary acid, so no polyatomic ion, only Cl negative. So if you combine Cl negative with H plus, you get HCl. Okay. Does that answer your question, Alicia? So Alicia, are you still there? You can tell me in the chat if that makes sense. Look at the equation that has oxygen. What do you mean by the equation? So yeah, so there's no equation, yeah, but when you look at the formula, maybe is that what you're saying? So if you look at the formula, if it has an oxygen, so see, I'll say the same examples again. Yeah, you're right. When you see oxygen, there will be oxy. So when you see any polyatomic ion, so 3 examples: HCl, HClO3, HClO2. Both of these are oxy acids. So yes, when you have oxygen, you have oxy acid. When you don't have oxygen, that's a binary acid. And then you apply your rules that we just learned. Right, great. Do we have more questions? Any other student wants to ask any question? not, then Alicia, you can ask me more questions. How do you tell if you need to look for molar mass in the equation? So when you start doing your chapter 3, if there's any question that has to change either, see there are 3 things, right? There's mass, then there's moles, and then there's number of either atoms or molecules, could be anything, okay? So whenever you need to move from moles to mass or mass to moles, whenever you're doing this change of mass to moles, so let's say I have half mole, and then you want to change it into mass, you use molar mass. If I give you mass and you want to change it into moles, you use molar mass. So this is where we're gonna need to find molar mass from periodic table. Does that answer the question, Lucia, or do you have a specific question? Yeah, sure. So let's say I give you that I have 0.84 moles of carbon dioxide and ask you how many grams CO2 is this, okay? Let's say this is the question. So you're given moles in this question, and then you're being asked the mass. You see grams means mass. So we're being asked the mass, to look for mass. Or it could be the other way. I could give you the mass and ask you for moles, give you mass and ask you for moles, or give you mole and ask you for mass. In both the cases, we need molar mass. So let's say we got 0.84 moles of CO2, and then we're gonna do this thing to the conversion factors. Now, what we're gonna put down here is gonna be the exact same unit that we have here. So this is moles of CO2, so we're gonna put moles of CO2 down here. And up here, since we're trying to go to mass, we'll put the mass here, grams of CO2. Now this is where we need the molar mass, that 1 mole of CO2. Now I have it memorized, but you will have to find that from periodic table. That carbon is 12.01. 2 oxygens are gonna be 32. So total is gonna be 44.01. So you put that number here, 44.01. So that's where we need the molar mass. And then you just multiply these numbers and you get the answer. So whatever you're gonna get here when you multiply these two, that will be your final answer. Let me take out my calculator. So 0.84 times 44.01. That's 36.9684. So this many grams of carbon dioxide will mean that it's 0.84 moles of carbon dioxide. Now you could be asked the very opposite question, where I give you, if we have 54.86 grams of CO2, how many moles is that? If that was the question, then we'll just do the opposite way. We're given the mass, 54, so you always start with what is given. And always put the units, so grams of CO2. So So we're going to put again here grams of CO2 because we're going to cancel them. And here you're going to put the moles of CO2. Again, the same thing. 1 mole is 44.01 grams. We figured that out earlier. We used the same number. And now you just divide them. So your 54.86 divided by 44.01 is going to be 1.25 moles of CO2. Okay. Does that make sense, Alicia? Okay, anyone else wants to ask any questions? You guys can also put your questions on the chat, or you can unmute yourself and ask me questions.
When it's multiple conversions, like let's say it's I guess mass to moles to, I guess, what would it be? Avogadro's number?
Yes. So let's do that kind of example, okay? So let's say we are given, if we have 98.46 grams of oxygen, then how many oxygen molecules are there? Okay, so the question is giving you the mass and it's asking you for molecules. So if you try to see that thing again, we are given mass, we are being asked number of molecules or atoms. So you see how this is going to be 2 steps. We're given mass, we got to first go to moles, and then from moles we go to number of atoms. So this is where we have to be careful that we remember this in the order. If you're given mass and you want to go to number of atoms, you cannot do this in 1 step. We have to do it in 2 steps. So who's going to help us here in the first step? Molar mass. Who's going to help us next? The Avogadro's number. So the Avogadro's number, that's what it's going to, the 6.022 number, that's what's going to help over there. So if we try to do that here, again, we're given mass. We're going to change mass to moles, and then we change moles to number of molecules. So this is what our steps should look like. Okay, are we good so far?
Yes.
Okay. So we are given mass, 98.46 grams of oxygen. So now we know this is going to be 2 steps, so we'll just draw 2 steps. This is grams. So what unit should go in the bottom?
Grams.
Grams of oxygen. What will go on the top is, we're trying to go to moles first. We'll put moles first, moles of oxygen. Then we'll go to next step, which should go down here.
That'll be moles too.
Moles of oxygen, and we'll go on the top.
Avogadro's number?
Yeah.
Molecules?
Number of molecules, right?
Mm-hmm.
Number of molecules. So again, mole to mass, this is 1 mole is 32 grams. Again, this is coming from periodic table. We'll find that from periodic tables. And then moles to molecules, we know that 1 mole of anything has 6.022 times 10 to the power 23 molecules. So now we just need to solve the whole thing. Again, I will leave the exponent out so I don't have to do this on the calculator. Again, I'll do the calculation on the calculator and then put them right here. Okay, what I'll do first is 98.46 times 6.022. 98.46 times 6.022, which gives me 592.92612 times 10 to the power 23. So I'm leaving that out right now. 10 to the power 3 divided by 32. Now what we'll do, if we divide this by 32, we get 18.5289 times 10 to the power 23. So that's your final answer. This is how many molecules we got. Now if you want to change this into presentation, you can. But again, I'm not going to require everyone to change this into a scientific notation. But just for the sake we're doing it, this becomes 24. And now if you also want to look at sig figs, again, I'm not going to take any points off for sig figs. But if it's a multiple choice question, you will have to see the correct answer. So in our question, we got 4 sig figs. So we'll stop this thing at 4 sig figs, so 4 significant figures. So this will become 1.85 and 3 because this is 8 that we are dropping. times 10 to the power 24. That's how many molecules of CO2 we got.
Okay.
That make sense?
Yes.
Okay. Does anyone else have a question on this? Did that make sense to everyone? Okay, Alex, you got a question on naming. What element is shown in figure out if you use 8 or 8 and then whole acid part would be different. Okay, yeah, no, you're right when you're saying that if you're given a molecule and you have to name it, you have to first identify. Now we're only focusing on acid right now, right? So when you talk about acids, you see an acid, you first need to decide whether it's binary or oxy. After you're deciding it's oxy, which means you're seeing a polyatomic ion inside, you decide whether it's 8 or 8. And then you name it. If it's 8, then you're going to call it ic acid. If it's 8, you're going to call it us acid. If that's what you mean, you're right. Does that answer your question, Alex? Great. Because if you can unmute yourself, it's much better to have the conversation if you guys unmute yourself. Then you don't have to write that much, and then I can get the response right away. But that's okay if you're at a very loud place. I understand that. More questions? What's the difference between molecules and mole in an equation? So molecule, when we say we have, if I say I have one molecule of CO2, then what I mean is I have just one molecule of CO2. This is what one molecule of CO2 looks like. And I have only one piece of that CO2. That's what we mean by a molecule. Okay? When we say we have 1 mole of CO2, when we use the word mole with an E, just mole, not molecule, just mole, then what we mean is we have 6.022 times 10 to the power 23 CO2 molecules. So molecules is one entity, like one thing is molecule. But when you have tons of them, how many? 6.022 times 10 to the power 23. If you have that many of them, we just call that a mole. Okay? Again, remember mole as dozens, and then you can have apples. So if you're counting fruit, that's like molecule. If you have one apple, you have one apple. But if you have 1 dozen of apple, then that means you have 12 apples. So same thing as mole. I guess I'm waiting for your questions. What's the difference between one? Okay. Yeah, so this will be posted. This is getting recorded right now. So after we'll end this in like 20 minutes. It'll take me like 20 more minutes to render the video, and then I'll post that on Canvas.
Do you mind just reviewing what's going to be on the next test a little bit?
Next test.
Yes.
We're right now too far from talking about second test because we haven't covered much material, but it's going to be your nomenclature and then chapter 3 and chapter 4.
Okay.
If you want to go ahead and study more, then first finish chapter 3, then chapter 4, and of course nomenclature. For the equation, what exactly do you mean by equations, Alicia? Are you talking about the question? So the way the questions are going to look like is like this. See this wording? If we have 98.46 grams of oxygen, then how many molecules are there going to be? Now also, if you want to do real questions, you guys go to Canvas. Okay, let's see the Canvas. So you will see there's a bunch of questions on Canvas.
I have one here from one of the labs. Can you see it if this maybe, I don't know if this might be too advanced in the class yet, but it says a mixture of sand and salt is found to be.
There right now, it's not that relevant with the exam part. I mean, there's
Okay.
a question. There are two questions like that on the lab. But first, we'll get moles and all of that first, and then we'll talk about later about the percentage and all of that. So right
Okay.
now, if you guys want to, practice on this, then I will say you guys go to your Canvas and then go to modules. So if you guys can see the screen, go to modules, and then under modules, you're gonna find. Also, if you're asking me where the video is gonna be, they're gonna be posted here. Okay. So it will say something like this: office hour recording, and inside here, you're gonna see it. And then you guys, if you're talking about the review, then you guys see here, multiple choice worksheet. Go to moles, mass, molecules. So you open this one, and then you see this question. The very first few questions, we haven't covered directly those in the class yet, but I'll cover them when we meet on Wednesday. So what I would say for right now is start from here. Question number 6. Let me see question number 5. Yeah, so start from question number 6. This is how the questions are going to look like. How many moles of CO2 are there in that many grams of CO2? There are dash molecules of ethane and that many moles of methane. Then you got mass and then asking for moles. And then you see given mass and then asking for molecules. That's one like we did right now. Then atoms, and you have to change it into mass. Or you're given mass, by the way. And then here, molecules to mass. So you can do all these questions. These are all questions. That's how your exams questions are going to look like, okay? And now, not just that, if you go back and then look at more questions, like net ion equation, empirical formulas, stoichiometry, this is all chapter 3 and 4. So we'll be covering this in the next 2 weeks. And then also you guys can also look at the exercises, okay? If you go to exercise, I think, let me open E real quick. Yeah, no, not this one. I'll try to rename these more clearly. Yeah, this is stoichiometry. Again, this is something we'll be doing next week. Yeah, but for right now, what I would say is do the beginning of lab number 12, and then do this one, mole, mass, molecules. And if you're done with all of that, you can also do your textbook questions. and you will get an idea on how the questions will look like. So first is do the question that I did in the class to get a good understanding, and after that, go to these practice problems. Right. Because that's due on Wednesday, and I'm pretty sure will that consist of more complex naming. No, it's gonna include whatever. If you have done your exercise C, lab number 8, and whatever I was covering in the class, you're gonna see problems like that. They should be just like that. Sure. Also, if you want to do even more practice, there's actually just this activity 1. You can even take a look at that one. So this activity, if you go down in the activity on the second page, you guys will see it has all these polyatomic ions. And the third page has more naming. If you guys want more practice, you can even do this page. The third page, the fourth page, you see, got more naming to do. You can even do these ones. Also for nomenclature, also there's a multiple choice worksheet, guys. See, do all of these. That's 13 pages. Okay, you guys got tons of things to practice. So formulas and then naming them, name to the formula, so you can see all of this. It also has the answers at the end, so you can see. I mean, at the end, I mean each question has the answer right there. You can do all these questions, guys. Just make sure you take a look at the whole canvas and then print these out if you guys like that. That's great, Alicia. Does anyone else have any questions? If not, then I'll end the meeting. But if you guys have questions, I'll stay.
No, thank you for your time, Aman.
All right, that's great. Anyone else have any question? That's great, guys, that you showed up to the office hours. Otherwise, I would be sitting myself. And that's why I'd like to do these virtual office hours, because even if you don't have to come to campus, you just do it from anywhere. So try to make to in as many of these office hours as you can.
Thank you. Have a good day.
You too. Right, that's great, Alex. All right, guys, so it seems like we're all done, so I'm going to end the meeting right now. And then the video is going to be posted on the Canvas. All right, guys?